Why are moving such heavy objects so difficult? That's because of friction. In this video, we'll learn about static and kinetic friction. We're gonna go through some examples and we're gonna see how friction relates to Newton's laws. Okay, so what is friction? What is friction? Friction is a force that opposes motion, and it acts opposite to the direction of motion. Acts opposite to the direction of motion. Okay. So there's two kinds of friction that we're going to learn about. There's first static friction, which prevents motion from happening. And there's kinetic friction that opposes an object's motion when it's moving. So what is static friction? Oh, and first, before we move on to static and kinetic friction, there's a force for the kinds of friction. There's an equation for the kinds of friction that's which is force of friction is equal to mu, which is the frictional coefficient. It's like what kind of surface it is, and times the normal force. So mu times normal force. So what is normal force? Normal force is, let's say you have an object sitting on the ground. There's a weight that acts downward, which is caused by gravity, and that's equal to its mass times the gravitational acceleration. And there's a normal force upwards, n, and it's balancing out the weight so it doesn't keep falling, and it's the result of the surface pushing back up on the block. And since the object isn't moving, these forces are balanced, and that's why the normal force is equal to mg. So we can write that as the force of friction is equal to mu, the frictional coefficient, times mg. Okay, now let's move on to static and kinetic friction. So static friction, it prevents motion. So let's say we have a guy pushing a big box and it has a lot of weight. So let's say the weight is equal to mg and the normal force is mg. Okay, and he can't push it. It's really hard to push. He's applying all the force he can. Let's say that force is 20 newtons. Let's just say that it's a force. But then you have the frictional force that the surface is creating, and the reason why he's not able to push the box is because the frictional force F sub F is a lot greater than the force that he's acting on, or just greater than the force that's acting on. So what does that mean? That means F sub F, the frictional force, is greater than F. So what does this have to do with static friction? So we know that static friction, it prevents motion. It prevents motion from happening. So here we can see that it's an example of static friction. The friction is so high that it's preventing the big box from moving, even though there's a force acting on it. That is what static friction is. Now let's see what kinetic friction is. Yeah, let's just do it right underneath. Same scenario. There's a big box, and the guy is applying a force. And here friction is opposing as well from the surface. From the ground, yeah. And let's say the box is moving. He's able to counteract the friction, and his force that he's applying is now greater than the frictional force. So that's why the box is moving right. This is an example of kinetic friction. What is kinetic friction? Kinetic friction is the friction that opposes an object when it's in motion. So even though that the object is in motion, it's still there's still friction that's applied on the big box. Kinetic friction opposes an object's motion when in motion. So this is an example of kinetic friction because it's in motion and it's opposing it. Okay, so those are the two kinds of friction that we have, static and kinetic. Now, let's relate this to Newton's second law. Newton's second law is the equation F is equal to ma, and it just means that if you divide by m and m, the acceleration is equal to the force divided by the acceleration of an object is equal to the force divided by the mass. So let's just use F is equal to ma. And also I have a video on Newton's second law if you want to watch that. Let's use the diagram of kinetic friction. Because here there's an acceleration of a. That means the box is moving, so we can use Newton's second law. Okay, so F equals ma. Let's just see how friction affects this formula. So you have your force F. It's acting in this direction, in the right direction, and you have your frictional force, F sub F, and it's acting in the opposite direction. The frictional force is opposing the force that the person is applying on it. And that is equal to ma. So that shows that the frictional force is causing the box to accelerate less. If there was no frictional force, the box would accelerate even more with a greater magnitude. So that's how friction relates to Newton's second law. So now that we've learned about the two kinds of friction and how it relates to Newton's second law and the acceleration, let's now solve a problem. Okay, so here's our problem. What is the acceleration of a hockey puck that has a mass of 0.1 kilograms if a hockey player hits it with a force of 20 newtons and the coefficient of friction of the icy surface is 0.005? Okay, so let's start with a quick diagram. You have a hockey puck and it's on an icy surface. And we're going to draw that in some blue. And you have a hockey player hitting it rightwards, or hitting it in a direction with a force of 20 newtons. And the object has a mass of 0.1 kilograms. So what does that mean in terms of normal force and weight? So that means it has a weight is equal to mg, and by plugging that in, what the mass is, 0.1 kilograms, times g, which is the gravitational acceleration, and it's just 9.8 meters per second squared. So that means that our weight is 0.98 newtons. And since the hockey puck isn't falling into the floor, we can say that the normal force is 0.98 newtons as well, because the normal force and the weight are balancing each other out. There's no vertical displacement. Okay, if the surface has a coefficient of friction and the hockey puck is moving right, there has to be some friction that's acting in the opposite direction, in the leftward direction. And that frictional force is given by the formula we've learned, mu normal. it's right. It was this formula. Well, we know what n is, so we don't have to plug in mg. So let's find what the frictional force is. So F is equal to mu n, and that means we know what mu is. Mu is 0.005, and n is 0.98. So let's solve that. 0.005 times 0.98. It's 4.9 times 10 to the power negative 3, or we can just write that as 1, 2, 3. We can write that as 0.0049 newtons. So that's what our frictional force is. 0.0049 newtons. So clearly we can see that the frictional force is really, really small, and that's because it's on an icy surface. So now let's try to find the acceleration. And we can try using Newton's second law, F is equal to ma. Okay, so clearly the puck would still be moving in the rightwards direction where the hockey player hits it, because the hockey player hits it with so much more force than the frictional force. So we have our 20 newtons minus the frictional force, which is 0.0049, and that's equal to the mass times acceleration. The mass is 0.1, and the acceleration is what we have to find, so 0.1a. So let's first start with the left side. So 20 minus 0.0049, that's equal to 19.9951. So clearly the frictional force is so small that it barely has an effect on the force acting on the puck. Let's divide by 0.1 on both sides to get a by itself, and let's just write a over here, the acceleration over here. So dividing 19.9951 and 0.1, we get the acceleration is 199.951 meters per second squared. That is our acceleration. Here we used our formula for friction and Newton's second law. So that was a pretty good problem that sums up what we've learned so far about friction in this video. And that is what friction is. That's what the friction is, and that's what static and kinetic friction is. So a quick summary on the video is that friction is related to normal force by the equation F. The friction is equal to mu n, mu times the normal force. That's how friction is related to normal force. And static friction just means that static friction is the friction that prevents motion, and kinetic friction is the friction that opposes an object's motion when it's already in motion. So that is a quick video on friction. Thank you for watching.